Okay, in this lesson we're going to be talking about the unit sine wave and cosine wave. And real quick, let's go over here. If you look at this application and you focus only on the red, you can see as we move around the unit circle and it plots the x values and y values on the coordinate system on the right, you can follow the red dot, and that's going to be your parent graph of your sine wave. Okay, the second time around I want you to look at the cosine, and you can see that this is going to be your cosine wave, and also the green would be your tangent. But that's just a real quick look at what we're going to do more precisely over here. So if we're given this function, the parent graph, y equals sine of x, and we have these particular x values we're going to evaluate it at, I went ahead and just plugged this information in. It's just going to be, we're going to evaluate the sine of 0. So let's pull up your unit circle. Okay, before we start with these calculations, though, we have our unit circle on hand. We're going to say that a period all the way around is going to be 2 pi. The amplitude is basically the height, and it's the absolute value, and it's going to be 1. Okay, and always positive. We want to make a note that this is always positive, because we're going to look at it like the absolute value. Okay, the domain is going to be from negative infinity to positive infinity, so we can sometimes say that as the reals, negative infinity to positive infinity. And our ranges, remember that is our y values, and it's the bottommost, which is going to be -1, to the topmost, which is +1. And this is related to the amplitude most often, so we're talking about the unit circle in this case, so it's -1 and 1. But we're going to see this play out when we actually have these calculations, and this will make more sense in just a second. So let's go evaluate the sine at 0. So you come to the 0, what's the sine? Remember, this is your x is the cosine, the y is the sine. So what's the sine at 0? Good, 0. Then what is the sine at pi fourths? Go to pi fourths. What's the y value? Good. Square root of 2 over 2, but let me make a note. Square root of 2 over 2 is approximately what in the calculator? So we're going to do these as decimals because it's a lot easier to graph that decimal than it is to try to graph square root of 2 over 2. So let's just say 0.7. Alright, now let's continue on. What's the sine of pi over 2? We come over here. Sine of pi over 2 is 1. Sine of 3 pi over 4, that puts us right here. What is the sine of 3 pi over 4? Square root of 2 over 2, which we're going to go ahead and put the decimal representation of that. And sine of pi is going to be 0. And then I'm just going to go ahead and pause it and plug in the rest of these values, and you can check those. Okay, check your answers and make sure you get the same thing. Now let's actually come over here to the coordinate system and plot those. So 0, 0. And you want to plot these like the ordered pair. Pi fourths, net 0.7. Then you want to do pi halves, 1. Okay, so these are the actual order pairs. So at pi fourths, we're going to be at 0.7. At pi halves, we're at 1. 3 pi fourths, we're back at 0.7. Pi, we're at 0. 5 pi fourths. Roughly, it looks like these are scaled by units of 2. So that's what I'm trying to graph these. 3 pi over 2 is a -1. Back at -0.7 and at 0. So let's see if I can sketch this. Okay, so this is going to be the parent graph of our sine wave, and then let's also verify the period to go all the way around the unit circle, which we did. This is all the way around, is 2 pi. This is going to be a sine wave with a period of 2 pi. The amplitude is the height, it's the absolute value, so from here to here is 1. And then the domain is the leftmost. Now these things extend in both directions, like it can keep going on and on and on and on and on. So it extends in both directions. So that's why our domain is going to be negative infinity to positive infinity. And the range is the y value, so it's going to be the bottommost y value is -1. The topmost y value for this one is +1. You also might want to make the note that this passes through the origin. And the next one we're going to look at is the parent graph of y equals cosine x. So I'm going to pause it and plug in these particular values right here first, and then we'll get started. Okay, before we start evaluating, we're going to say that our period is 2 pi. The amplitude is going to be 1. Our domain is all real numbers, which again is negative infinity to positive infinity. Then we have range is going to be -1 to +1. So you can say your domain either way, all real numbers, or you can just leave it in interval notation. Alright, now I pulled this unit circle up, let's calculate. Cosine at 0. So we go to 0, the cosine's the x value. What's the answer? 1. Right, now let's move around. Cosine of pi fourths. So move up to pi fourths. What is it? Square root of 2 over 2. We recall from the last one, we would put this in the calculator, and it's approximately 0.7. So it's easier to for graphing when we use the decimal note representation of it. Let's do cosine of pi over 2, which is going to be 0. Cosine of 3 pi over 4, come over here, the y value is going to, the x value for the cosine is this negative 0.7, and then let's go to pi. Cosine of pi is going to be -1. Now I'm going to pause the video and you finish out the last 4 and then check. Okay, so check those. Now let's actually plot the ordered pair. So we're going to plot the x, y as an ordered pair. So we start with 0, 1. So we can see already that sine and cosine are different because the sine wave goes through the origin and the cosine wave does not. Pi fourths is 0.7. Pi halves is 0. 3 pi fourths is -0.7. Pi is going to be -1. We're here, and let me delete this out the way now. 7 pi over 4 is going to be 0.7. And then 1. So let's okay, so this is a somewhat parent graph for your cosine, where the period is 2 pi. So from here all the way around the unit circle is 2 pi. Amplitude is once again 1, which is hard to see here. This is a 1 and this is a -1. Domain, because this can extend forever and ever in both directions, negative infinity to positive infinity, and the range is the y value from bottom to top is -1, and the highest y value is 1. So range is -1 to 1.